Hi, my name's Nick. I'm a tutor here at Wismart, and today I'm going to be doing an introduction lesson to the programming language Python. So, who am I? Like I said, my name's Nick Vecchione. I'm a junior at UC Berkeley studying electrical engineering and computer science with a minor in data science. I'm originally from San Diego, California, and I love programming, playing guitar, hanging out with friends, listening to music, and love going to the beach as well. Um, and yeah, like I said, I'm a tutor slash teacher here at Wismart. I really enjoy teaching Python, and I love sharing, you know, knowledge and the ability to program with people because I think it's a really cool skill to know, and I think that everybody should try to learn it at one point or another. And yeah, I really enjoy Wismart because it's a great platform to teach people and to tutor on. So let's get started. So what is Python anyways? Well, simply put, moving my video over a little, Python is a programming language. So specifically, Python is an interpreted, high-level, general-purpose programming language. And so a programming language is just a language for coding. And you can imagine it a lot like languages that we talk about, or languages in the sense that we normally think about languages. For example, English, Spanish, French, Chinese, etc. In programming, there are many different languages that we can code with. However, using these different languages, we can oftentimes accomplish the same goal that we're trying to do. Don't worry too much about what interpreted high level means, but general purpose just means also that it's a general language, and as we see below, Python is considered by many to be one of the most powerful programming languages in the world for its simplicity and versatility in application. And Python can be used for user interfaces, websites, applications, really anything you want to program in Python, you can. And it's really a great language to learn. And in my opinion, it should be the first programming language that anybody learns because most people say that it's simple, it reads like English, the syntax is intuitive, and yeah. So throughout this course, we're going to be covering variables and types, mathematical operators, user input, comments, comparison operators, conditional statements, loops, break and continue, nested control structures, functions and exceptions, and more. Most likely, all of those terms and words are completely meaningless currently. But as the course progresses, we're going to see by the end of it, hopefully, uh, you should know all of these terms and what they mean. But for today, we're just going to be looking at mathematical operators. So what are mathematical operators, and what does math even have to do with Python? So at a very, very basic level, in Python, the simplest thing you can do is just some math. Python and computers in general, as you're probably aware of, are very, very good when it comes to crunching numbers. And when I say crunching numbers, I mean performing calculations, doing big math, adding, subtracting, multiplying numbers together. So in Python, the 7 mathematical or arithmetic operators that we're going to be looking at are addition, which I'm sure you're familiar with, subtraction, multiplication, division, modulus, quotient, and exponent. So addition, subtraction, multiplication, division, I'm sure you're already familiar with. And the symbol for these operations are plus, minus, the little asterisk, which is on your keyboard above the 8, and the forward slash, which is the question mark button on your keyboard. And we'll talk more about modulus, quotient, and exponent in a little bit. And there's a difference between division and quotient, specifically. It's called quotient. In this case, refers to floor division. Don't worry what that means yet. Let's start with some examples first. So, oops. My apologies. Oopsie. Sorry about that. All right, so simply in Python, we can do addition using the plus symbol. So we can do something like 3 plus 9. Oh, also before we start, you can program in Python on many, many different platforms. There's tons and tons of different text editors and programs that you can use to write Python code. However, for Wismart and for teaching and tutoring purposes, I really enjoy using Jupyter Notebook, because it allows for you to add text and run your code instantly just by pressing Shift Enter. And so, yeah, usually when I'm teaching and tutoring, I like using Jupyter Notebook because, yeah, I mean, I think it's a friendly layout and, you know, it's pretty intuitive. So, anyways, first mathematical operator in Python that we're going to be looking at is addition. And these are going to be pretty simple examples, but 3 plus 9, we get 12. We can do 8 plus 19, which is going to get us 27. And so both of these addition expressions are pretty simple. We can write them out and do them on paper. However, you can imagine if we have two really big numbers that we want to add and we don't want to do all the math on paper. Python, like I said, really, really quick at crunching numbers, really quick at doing math. And we can see that running this little cell of code, we automatically get a result, which is the massive sum of, I can't even read that number off because it's too big. But as you can see, just typing out total, absolute, massive numbers and running the cell, Python is able to compute the sum just like that, which is pretty cool. So yeah, addition plus in Python, that's all it is. All right, so next is subtraction, really just the inverse of addition, meaning instead of increasing, we're decreasing something. So we can do like 9 minus 5, which is going to give us 4. We can also do something like 7 minus 1, 6, and then once again, we can do some, oops, I can't type. We can do some really big subtraction between big numbers. Or we can also do, a smaller number minus a bigger number, which is going to get us a negative result. And yeah, so pretty straightforward with addition and subtraction. Subtraction is minus sign to do, to get the difference between two numbers. And we can also string together multiple subtraction operations together. And so this long difference equation that I wrote out is equal to 189. And also for addition, we can do the same thing. We can also write out multiple, we have multiple numbers and add them up together. All right, cool. So next mathematical operator is multiplication. So like I said, to do multiplication, we use the asterisk or star symbol, which is you get by pressing Shift 8 on your keyboard. So 3 times 7, of course, we know that's 21. We can do 9 times 5, which is 45. And then once again, Python is really good at computing really big numbers, really big products really quickly. And still blows my mind that computers are this quick, but Python is able to handle these big mathematical calculations very quickly. So as a recap, asterisk for multiplication, and we can also, string together multiple asterisks, stars together to get, 3 times 3 times 9 times 1 times 3 times 8, which is 1,944. All right, cool. Next is division. So division, I'm sure you're familiar with it, is represented in Python by this backslash, which is below the question mark symbol on your keyboard. You can access it just by clicking it, or tapping it, pressing it without using Shift. So for example, if we were to do 8 divided by 4, we're going to get 2. Python puts this in decimal notation with the dot and the 0 afterwards, because, for example, if we were to do 9 divided by 4, we would get 2.25, which is the result. So yeah, Python just, for the backslash, normal division operator. Normally the result is in decimal. And so once again, we can do lots of division or string a bunch of division operations together. So we could do 10 divided, or not 10, 100 divided by 5 divided by 5, which is going to give us 4, I believe. Yes, 4.0. And in addition to all the other mathematical operators, Python is very, very quick at calculating these big quotients and calculating what, you know, this massive number divided by this other number is to get this result. And we get the exact decimal expansion up to the tens, hundreds, thousands, etc. places. So pretty cool. And, you know, we can also divide smaller numbers by bigger numbers. So if we want to figure out what 7 divided by 33 is, we find that it's 0.211, 0.212121, and so forth and so on. And we could also get, you know, really small numbers as well. So this is 2.9 times 10 to the negative 14th. If you're not familiar with this notation, don't worry too much. We'll be talking about it later. But this basically is just a very, very small number. All right, cool. So going back to, going back to the slide, so far we've looked at addition. So 4 plus 7 gives us 11, subtraction, minus sign, multiplication by this asterisk, division by this backslash, and finally we're going to be looking at the last 3 mathematical operators I want to talk about today in this mini video lesson, and that's going to be modulus, quotient, aka floor division, and exponent. So floor division. So we just looked at division, and we noticed I made the point that whenever we do normal division with just this one backslash, excuse me, we get the decimal, the tens, the hundreds, the decimal parts of these numbers. So notice that we get 25 here, we get O here, we get 0.3395224. We are getting the fractional component of all of these division operations. However, sometimes when we're programming it in Python, we don't necessarily care about the remainder or the decimal part of the number. So that's where floor division comes in, and the slide calls it quotient, but most people call it just floor division. And the reason why it's called floor division is because we floor things down. And I'll explain what that means. So if we do, for example, 7 floor divided by 3, we are going to get 2. So notice in contrast, if we do 7 divided by 3, we get 2.33223 as expected, which is 2 1/3. But floor division instead allows for us to basically cut off this fractional component from the division operation. And so yeah, this is, as we continue in the course and learn more about Python, we'll see where this comes up often, where we don't care about the remainder in a division operation, and we only want the whole number component, if you will. So we can also do like so if we were to do 6 divided by 2, we get 3.0, but if we do 6 4 divided by 2, we get 3. And then we can also do, 75 4 divided by 9 or 8, and that'll get us 9, because if we look at 7 divided by 8, it's 9.375. And so as a little note, floor division is just normal division, but we cut off the fractional component. In CS or programming terms, this is called truncation. You don't have to worry too much about the definition of truncation, but just know that floor division, using these double backslashes, cuts off the fractional or decimal part after the period, the decimal point. All right, cool. So we just talked about floor division, and the reason why it's called floor division is because we can imagine we have, for this case, 9.375. We have 9.375 and we floor it down to 9, aka we like round down. And that's pretty much what floor division is. you're dividing and you're rounding down to the nearest integer, as we can see in these examples here. And just for one more, for clarity's sake, you can see that 9 divided by 4 gives us 2.25, but 9, 4 divided by 4 is going to give us 2. So yeah, floor division, normal division, but we cut off the fractional component. This is called truncation, where we remove the last part. So we just talked about getting rid of the remainder of the fractional component in division. However, as you're probably familiar with from learning division in elementary and potentially middle school, with long division, we have a remainder usually. So, for example, if we divide 7 by 3, we get a remainder of 1, right? Because 3 goes into 7 2 times, and then there's 1 left over. So we can write this as like 2 times 3 plus 1 equals 7. So sometimes when we're programming, we care about this remainder. Sometimes we don't. And so that's where the modulus, aka remainder mathematical operator, comes in. So let's say we wanted to find the remainder of 7 divided by 3. Well, that's where this percent slash modulus operator comes in. Don't worry about the origin, the etymology of the word modulus, but just think of it as a remainder operator. And so yeah, the percent symbol is, you access it by pressing Shift and 5 on your keyboard. And as we expect, since this is the remainder operation or operator, when we do 7 modulus 3, or 7 mod 3, 7 is usually what it's called, we get 1, since it's a remainder of 1. And we can see this with other examples. If we do 18 modulus 5, we're going to get a remainder of 3. So that's what we get. And then once again, well, before we do big numbers, let's do one more small example. If we do like 57 modulus 13, we'll get 5. And that's because we can do 13 times 4 plus 5 gives us 57. So 13 goes into 57 4 times, and then we have 5 left over, and that's why that's the remainder. So yeah, we can also do really big remainder operations. Once again, Python, very, very quick at calculating big remainders of any big calculations that you want, which is pretty cool. All right, so awesome. So that's remainder, and then yeah, we looked at floor division. So we can think of floor division and modulus, aka remainder, the remainder operator, as being kind of opposites of each other, where floor division gives us the floor division gets rid of the remainder, and modulus gives us the remainder. So yeah, hopefully that makes sense. I think it's pretty self-explanatory, but yeah, just recall that this percent symbol in Python represents the remainder or modulus operator. All right, now finally, we're going to be talking about exponentiation, aka the exponent operator. And going back to the slides, so as we're looking at our modulus and quotient or floor division real quick, we see 10 mod 4 is 2 because there's a remainder of 2, and then 18 4 divided by 5 is going to give us 3 because there's a leftover remainder of 3, but we just cut it off, we truncate it. All right. So finally, final mathematical operator I want to talk about, arithmetic operator, is exponent, exponentiation. So oftentimes in Python, we want to take things to an exponent. So sometimes, let's say we wanted to multiply 3 times 3 times 3 times 3 times 3 to get 243. So that's kind of annoying having to type out all of those asterisks, all these multiplications, and string them all together. And that's where the exponent mathematical operator comes in. And if you're not familiar with exponents, It's basically just shorthand multiplication compacted with one number over and over again. So the exponent operator is represented by 2 asterisks instead of 1, 2 of these star symbols. And running this, we see that we get the exact same result as we did before, but in a much nicer and more compact notation. So what this means, this double star, is we are multiplying 3 by itself 5 times. So this and this are logically equivalent, hence why they spit out the same result. But so this is just 3 to the power of 5, if that makes sense, which is equal to 3 times 3 times 3 times 3 times 3. We can also, so this was a more simple example with only 3 to the power of 5, but we could also do 3 to the power of 100, which is a really, really big number. And so this is 3 times 3 times 3 times 3 times 3, 100 times. So we're multiplying 3, 3, 3 over and over again, and there's 100 threes total that we're multiplying over and over again. So that's a nice notation, handy mathematical operator now, because it allows for us to do raising things to the power and doing exponentiation, shorthand multiplication without having to write out a bunch of asterisks. And as some more examples, we can square numbers as well. So 6 to the power of 2, aka 6 squared, we know is 36. We could also do something like 4 to the power of 3, which is going to give us 64. And also, you know, Python is just for fun. So it looks like I actually typed in too big of an operation there. But if we shorthand that a little and do this, you know, 8 trillion to the power of 312. As you can see, this results in a really, really, really big number that we can't even really fathom how big it is, but Python's able to calculate it. Python's able to compute it in under a second. The example I gave before where it lagged out, that was a little too big. The result was going to be probably thousands upon thousands of digits, so Python was a little slow. If I let it run for a bit, probably would have figured it out, but just for the sake of time, I chose a shorter one that calculated a bit quicker. So yeah, and you know, 9 to the power of 2 is 81, and then one more example, 7 to the power of 3. I don't know off the top of my head, but Python says it's 343. And so yeah, this is once again the same between 7 times 7 times 7. Awesome. So great. So as a recap, we looked at addition, subtraction, multiplication, division, modulus, which is remainder, quotient, aka floor division, and exponent. And yeah, the examples give how all these arithmetic operators work pretty simply. So as shown by the examples I just did, at a very basic level, Python can act as a calculator. In other words, you can type in whatever mathematical expressions you want, and Python is smart enough to be able to calculate the answer, no matter how complicated it may be, most of the time within reason. And so yeah, Python's pretty smart when it comes to doing math and calculating mathematical expressions, as we saw in the examples I was just doing. So in addition, there are a few rules regarding the use of these arithmetic and mathematical operators, which we'll get to in a future lesson. But for now, I just want to lay the basic framework, and really for any programming language, especially when you're starting to learn Python or programming for the first time, you just start out learning these math operators because lots of code revolves around being able to utilize math in some way or form. And when I say math, I'm not talking about any complex, you know, calculus or anything crazy like that. I'm just talking basic arithmetic, addition, subtraction, etc. All right, well, that concludes today's mini lesson, going over the arithmetic operators, math operators. I hope you enjoyed this brief introduction to Python. Of course, there's so much more to learn, but this is just the beginning. Programming is, like I said, a great skill to learn, and I highly recommend pursuing it further. It's a ton of fun. And thank you again for listening, and please feel free to go over the video and look over any of the topics, and if you didn't understand anything, as I hope I explained it in a good way. All right. Well, thank you. Bye-bye.